Let's begin. Welcome everyone to tonight's proceedings, both here in the at the Ellery Theatre in the Royal Society of Victoria, and we have lots of people tonight also on the Zoom webinar and live streamed on YouTube. My name is Rob Gell. I have the pleasure of being the President of the Royal Society of Victoria. Before we begin, in a spirit of reconciliation, we acknowledge that all of us are located on the traditional lands of this state's first scientists, many different First Nations peoples who belong to the diverse lands and waters of what we now call Victoria. We're coming to you, of course, tonight from the lands of the Wurundjeri Woi-wurrung people, and I invite everyone joining us tonight either via Zoom's webinar chat function or YouTube's comment section for those following on the live stream to acknowledge the traditional custodians of your own local country and join me in paying respects to elders past, present, and in that respect to any Indigenous Australians who have joined us in the meeting tonight. Before I do begin and introduce our special guest speaker, I'm delighted that joining us, we have a new Vice President at the Royal Society of Victoria, Professor the Honourable Carolyn McMillan. As many of you will know Carolyn. We've had some discussions and I've been able to persuade her to join the council, and she seems to be still most enthusiastic about doing that, which is good. So some of you will know her as formerly the Vice Chancellor of the University of Newcastle and State Scientist in South Australia, amongst many, many other wonderful things. So we're looking forward to working with you, Carolyn, and welcome to the Society. Probably for your first lecture here, is it? No. So tonight we're delighted. We're delighted to be joined by Professor Patrick De Decker AM for his presentation on Holocene climatic fluctuations in the Australian region. Patrick is our 2023 Medalist for Excellence in Scientific Research in Category 3 Earth Scientists. And our Medal for Excellence is our most prestigious award that the Society awards annually. I'll tell you a little bit about Patrick's research career before I hand over to his nominator, who happens to be Professor Peter Gell, to give us a more informal overview. And Mike, I was going to ask you, is this the first time there have been two emeritus professors of paleoecology, sorry, that's a bit brief for you, in the Royal Society at the same time?
I'm not sure. I think they're pretty thick on the ground, those paleoecologists, so it's very, very likely.
Professor Patrick De Decker, AM and Fellow of the Australian Academy of Science, is an emeritus professor based at the ANU College of Science. Patrick pioneered the study of quaternary history of the oceans bordering Australia, that's the last 2 million years, and has principally used microfossils and their chemical composition to reconstruct past changes. It was also first to link patterns of environmental change on land through salt lake records, and at sea, again using microfossils and other proxies. He has found that during the Holocene, the oceans have progressively warmed. Now, when was that, Patrick? Because I think that's probably common knowledge today, but that was some time ago. That's right. Yeah. His most recent innovative research deals with the microbiological and geochemical fingerprinting of airborne dust, with the aim at linking dust events with changes in the oceans. Patrick completed his PhD in the Department of Zoology at the University of Adelaide on salt lakes, their biota and quaternary lacustrine deposits, a field he continued during his postdoctoral positions. He then obtained a DSc from the same university, this time from the Department of Geology and Geophysics, which is a nice switch as well, for long-term accomplishment in the fields of limnology, paleolimnology, paleoceanography, and micropaleontology. And my brother informs me you could be otherwise described as a limnogeologist, which I don't think I would have heard that before, but it's a really nice thing. In 1998, Patrick joined the Australian National University and held a full-time teaching position combined with research up until his recent retirement. Throughout his career, Patrick's work has been multidisciplinary in nature, with a common aim to obtain information of relevance for the reconstruction of past marine and continental environments of importance for the understanding of global and regional climatic variability. In recognition of his efforts and achievements, he's been awarded the Virchow Medal in 1992, the Australian Society for Limnology Medal in 2005, the Christopher Plantel Medal in 2008, the Mawson Medal in 2010, and the Brady Medal in 2019. And tonight, a little later, the Royal Society of Victoria's 2023 Medal for Excellence in Scientific Research. In 2007, he was appointed a member of the Order of Australia for his research and teaching efforts, and an officer of the Order of Leopold II by the Kingdom of Belgium in 2018. My brother tells me that's about drinking Belgian beer, and for outstanding achievements in science. So much for my formal account. I'm now going to hand over to Peter to give us a more visceral reading of Patrick's research adventures. Peter.
Okay, thanks, Rob, and congratulations, Patrick. And I first met Patrick when he came down to Monash from the ANU in the mid to late 80s, where he set about tormenting ostracod crustaceans in beakers by denying them the solutes they needed to build their shell. I thought that was rather an unjust way of treating animals, but of course that work went on to develop the geochemical analysis that we use around the world today, which enables us to look at the geochemistry of those shells and independently reconstruct both temperature and salinity from the same sequence. Pioneering work back in the 90s with Alan Shivers. He also set upon tormenting the postgraduate students, and I remember very well standing on the core in the northwest crater at Tower Hill, taking the sediment core, and Patrick insisting that we twist the rods as hard as possible to make sure that the coring head closed, knowing full well that the previous year the rods had snapped and we spent a whole day trying to retrieve our equipment. So we weren't very happy with Patrick putting pressure on the coring equipment. But of course, again, that work led to a 16.5 metre sediment record, which is the longest handheld core from Victoria, I believe, only beaten by Peter Kershaw's 17 metre core on the Atherton. And the basal age was 20,000 years, and it set the age of Tower Hill back from what was thought to be 5,000 years back into the Ice Age, and enabled us to have a closer look at the nature of Ice Age glacial landscapes, vegetation and lake condition through that time. Patrick was instrumental through his international contacts in enabling me to get a post at Université de Paris Sud, where I spent a couple of years. And I remember Patrick coming visiting for a month, and we would, over a Belgian beer or two on a Friday afternoon, chuckle at various vaudevillian things that would happen within the laboratory in France, such as there being no toilet paper for a month in any of the toilets in the building. And of course, having only 3 phones on the floor, the secretary in the central office had to call out to any professor who had an incoming call, and he would trot down the corridor to receive his phone call publicly in the general office, which we found quite curious and very French, of course. Those contacts led to Patrick having the privilege of hosting the International Paleolimnology Congress in '93 in Canberra, which he did so with Robin Clark. And I had the privilege myself of sharing the pre-conference field trip with Patrick to the Western District of Victoria, whereupon we travelled up the west side of Victoria and introduced these international delegates to Lake Mungo, with Jim Bowler explaining all that history that he discovered in the 60s. So it was a lakes tour, and the people that came, because Patrick was leading the tour, including world's leaders such as Ray Bradley, Sherry Fritz, Neil Roberts, and Patrick's old mate Rick Forrester, of course, came along as well. Of course, Patrick has moved away from lakes and diversified into the ocean drilling, to dust work, but he continues these extraordinary international links through that emerging research, which I believe is still continuing from the CV I've seen. But of course, he continues to return to the lakes of Western Victoria, and we'll hear more about that today when we get a Holocene reconstruction, which of course I'll remind everybody goes up to today because the Anthropocene doesn't exist, as we heard a few weeks ago. So I'm very much looking forward to hearing Patrick give us an update on the Holocene in Australia. So congratulations, Patrick.
Thanks, Pete. I also have an email to share from Professor Jim Bowler, who couldn't be with us tonight, but he records his apologies and sends this message, Patrick, which I'm sure you'll enjoy. Jim says, Patrick Dede has that remarkable legacy, top of the tree in unexcelled study of Australian lakes. For almost a decade, we worked together on those challenges at the ANU. I must confess to some anxiety when Patrick turned from relatively manageable small lake systems to the big one, ocean studies. I need not have worried. Patrick's recent work has revolutionised so much of our understanding of the marine sedimentary record, with particular emphasis on climatic change and complex feedback systems. I retain a treasured copy of a 1981 RSV tribute, a much less worthy occasion than that you confer on Patrick this evening. So it's really nice to hear from Jim on such an auspicious occasion as this evening. With that, let's make Patrick welcome to provide his lecture, Holocene Climatic Fluctuations in the Australian Region. Welcome, Patrick.
Can you change the screen? And while he's doing that, it reminds me that when I was doing his experiment, growing these little ostracods in cool rooms at Monash University, I was sharing the room with 1 million blowflies that were also growing as experiment. Well, thank you very much. Indeed, I feel very privileged to being in this Augustus place. And
Your laser pointer.
okay, here.
Sorry. There you go.
Good.
And there we go.
Thank you very much. So I'd like to talk about the Holocene, the last 12,000 years of Australian history, and you will see there have been many, many changes. You have here at the bottom, at the top, you've got Blue Lake in the Snowy Mountains. I will talk about this lake, and Lake Keelenbeat, which was actually first studied by Jim Bowler, and you can see ancient shorelines indicating that the lake level has changed. I'd like to acknowledge the first inhabitants of Australia who have lived through 50,000 years. That's about 2,500 generations through climatic changes from a wet to a very dry Australia. And I feel very privileged to be able to work and describe more about human activities in Australia. So my first experience started when I left Adelaide University and I went to the ANU to work with Jim Bowler, who had envisioned an amazing 5-year program to core large salt lakes. And the reason being that large salt lakes at some stage, like Lake Eyre today, at some stage, Lake Eyre was 5 times the size of what it is today. And how was the climate like? So we spend a lot of time studying these lakes, and these are the machines that we used on these salt crusts at Lake Eyre, Lake Buchanan. But also the bottom slide shows you dust being deflated from the lake floors, and they go in different directions. The colors indicate a different nature of the clays. And ever since knowing about this, I actually started looking at clays, airborne clays in the ocean, and tried to link environmental change in the ocean and what happened on land as well. So just take an example of this very large Lake Buchanan in central Queensland, very saline on this plateau, and you can see some ancient shorelines of this lake, indicating that at some stage, the lake had a lot of water. However, the BM boundary, that's a Brunus-Matiyama boundary, it's about 780,000 years ago, is at 5 meters. So 5 meters of sediment representing such a long period of time. So material must have been lost, material must have been deflated. And that's what led me to think that maybe I could find the answer in the ocean. And you have here a crater lake, Noatak. It's like a gigantic rain gauge. So the principle is this. You have a crater lake with a very well-defined catchment, and it rains in that catchment. And you also have some salts, sea salts that drift around. Lake Noatak is only 50 kilometers from the sea. So the lake is very salty. Today, it's twice seawater salinity. So the principle that I used in seawater, in red, the box in red is 35 grams of salt in seawater, and that's 35 parts per 1,000 or 35 salinity. Lake Noatak today, twice that amount of salt. However, if 100 years ago, Lake Noatak had more water, so it still had 70 grams of salt, but the salinity was halved because of the dilution. And in the past, about 3,500 years ago, the salinity was 140 parts per 1,000 grams per liter. So I used those proxies to tell me about climate change. So there are principles worth considering with respect to past climate. Australia is a disadvantage because, as I said, you have a loss of record through deflation of the weathering and soil formation. So I don't know what to do with this. There are long records of environmental in the ocean because it's more or less continuous. Okay. Thanks. Enough. Yeah. And the marine records, these piles of sediments, just like the books, the pages in a book, like the archives, I can correlate with what happened in the ocean around Australia, but elsewhere in the world. And then I can find terrestrial pollen, clay, deposit from rivers in the ocean. So I can see and say what happened between the land and the ocean, and I can determine if there are lags and leads between the two. A characteristic of Australia is that the southern hemisphere is a maritime hemisphere compared to the northern hemisphere. It's bordered by 3 major oceans, and Australian climate is dictated mostly by the ocean, what's happening in the ocean. And you have the Indo-Pacific warm pool north of Australia that borders around Indonesia and other islands. And then there are 2 currents that are offshoots of this warm pool that circumnavigate Australia. You'll see a map in a minute. So my principle has been to take a sample, the little box in white, and then I can extract a lot of things. In blue is a terrestrial archives, the pollen, the quartz from the wind, total organic carbon, barium and titanium, again produced by transfer of dust, and the clays. And then in mauve or pink, you have all the other proxies that I can obtain from the core. All that from one sample. I take 1 little centimeter and I can decant the pollen and so on. So it's been a time consuming, but I was able to say much more about what was happening in the ocean. Oh, shall I say postpone or whatever? And have a look at this map of Australia. And we actually went to look for many cores. And it's been a very difficult exercise at times. To go at sea for 1 day is $50,000, and you have to be with a large group of people. So today I will talk about 3 cores, and these are the red rectangles. one in northwest near Exmouth in Western Australia, and then 2 in Victoria and South Australia. Oops. So you have to remember that sea levels 20,000 years ago, sea levels were about 125 meters below that today. You could walk to Tasmania, you could walk to New Guinea, and you have a look at the periphery of Australia. You see where Darwin is and so on. And this warm pool, where there were a lot of people living there, was very, very different. And then sea level rose sometime at of the order of 1 meter every 90 years. This is a lesson to take because we are witnessing a sea level change. I will talk about this lake there, this core, and you just, the gray curve here indicates sea level change. And then we have a proxy to reconstruct sea surface temperature. And you have to look at the axis in thousands of years going back to 30,000. So around 12,000 years ago, the temperature was much warmer than today. And you can see after that, it declined. And then we have another proxy to look at the amount of rainfall. I'm not going to explain how we obtained that, but the summary is that at about 12,000, a monsoonal system started to appear in northern Australia, and ENSO started about 5,000 years ago. ENSO is the alternation between La Nina and El Nino. So these are the sort of information that we can obtain. And then there's a summary slide because I'm going to talk about the Holocene. The Holocene is defined as the last 11,700 years before present. Sometimes they say CE for Common Era. And so you can see here data for many sites around the world. And there's a period when the climate was at an optimum. It was very warm and wet. And then for the last 10,000 years, in red shows periods in Europe, which were warmer and others that were colder and dry. And you have the Little Ice Age, that some of us interested in wines know that you no longer could have grapes in the UK, and they switched to brewery. Now they're going back to grapes. And then the Holocene is divided in Europe, in the Northern Hemisphere, at several different periods. Have we got the same in Australia? That's the question. So there are some magnificent, outstanding changes during that period from 12,000 years ago. Population on the globe increased at an exponential rate towards the end. And today we're even higher. And the grazing and the crops of land are changed as well. And as a result, you have a huge amount of sediment transported by rivers, but that end up in the ocean. So a lot of significant changes. Were they related to or affected by climate? So there's another summary slide showing the Pleistocene, the period before 11,700. It was so dry and cold that a lot of vegetation animals were in the lowlands. And then at about 11,700, things went up up the hill. And this is for Asia, but we'll see what happened in Australia during that time. So this important slide, it shows North Africa for various periods. Before 8,500 and so on, you can look at the yellow boxes. Before 8,500, it was very dry. And the red dots indicate human settlement or human activities or implements and stone tools and so on. And when it became very wet, look where people went. A complete change. And then a bit later, it was still wet and people were away from the River Nile and similar rivers, became dry, they moved back towards the river. So what was it like in Australia? So here's I think it's a magnificent three-dimensional view of Eastern Australia. And you've got the elevation is exaggerated, but you've got on this figure, those sites that I'm going to talk about. And you can see the East Australian current that extends today is even further down to Tasmania, and the Leeuwin current that circumnavigates Western Australia and can reach Adelaide and even Victoria. So this is shown on this map here. I'll talk a little bit about a site of Macquarie Island and also an ice core in Antarctica. So here are some photographs of Blue Lake in the Snowy Mountains, some lakes in Tasmania, on Fraser Island, a cave in Tasmania. They looked at this, what I call speleothems. Some of you call them stalactite or stalagmite. Some salt lakes in Western Victoria and a lake in on Macquarie Island. So the first lake is there are two crater lakes in Western Victoria. I spend a lot of time there. Nortuck, as I said today, is very saline. And we consider them as gigantic rain gauges, and I gave you the reasoning behind that. So I'm now going to go look at lakes from the north, from Lake Mackenzie in Fraser Island, and people have reconstructed air temperature above the lake from the organic chemical composition of the sediment. And there's highlighted in red a period of time between about 8,000 and 5,500, a period when the temperatures were high. In the Snowy Mountains, Blue Lake, and people have looked at pollen in Blue Lake, and they found pollen of Pomaderus, a plant that does not exist around Blue Lake today. And also, we looked at little grains of quartz that we found in the lake. And so, just go for Pomaderus. Pomaderus was abundant between 8,000 and 5,000 years ago. So that's that red bar again. And then there was very little quartz grain, indicating reduced winds. And if time allows, I'm going to talk a little bit about the pygmy possum, this little possum that I can hold in my hand, that lives today at the snow line. And people are worried that it will disappear with climate improving. But I will argue that 5,000 years ago, when the snow line was above the lake, a pygmy possum must have lived. The big difference between what happened in the past and today is today the environmental change is extremely fast. The animal genetically hasn't got perhaps the time to recover. More about that later. So I had to mention Lake George, very well studied, and today is full of water. And again, looking at from 0 to 12,000 years ago, there are 3 phases when Lake George at very high levels. Again, the red bars indicate very similar to those events that I discussed before. There was a phase about in 1880 when the lake had close to 8 meters of water, and you had steamboats on the lake. But more about this later. So paleolimnology, the word that was mentioned before, is looking at archives in those lakes. And here we had a coring device with compressed air coming out like a rocket out of the wall. It's pretty exciting. The adrenaline is pretty good. But we got 4 meters of sediment, and these 4 meters are just like pages in a book. And 1 centimeter represents 2.5 years of deposition. So we can actually look almost at, on a yearly basis, what happened in this lake. And so these 2 crater lakes with ancient trees that are now coming out of the lake. But you can see again, this period of time, the red bar, when the lake, both lake levels were very high. And in Tasmania, 2 lakes, the vegetation, this is the percentage of rainforest taxa, well, the red bar, and you can see high rainforest taxa. And the same was found for other lakes near the Cradle Mountain National Park. And the palynologists have said after 9,000 years ago, fire activity declined and rainforest increased substantially. Today it's different. This cave in Tasmania, again, people looked at the chemistry of these stalagmites, speleotherms, and the conclusion is the warmest climate occurred between 8,000 and 7,400, followed by the wettest period. But again, the same window that I mentioned before. And then you go to Antarctica, and here's a photograph on an ice core with an ash layer. And here's a photograph of a similar ice core, and you can see the little bubbles in the ice core with the light behind. And people have been able to extrude the gases in those bubbles and measure CO2 and methane and so on. And during that period, that red bar that I mentioned, in Antarctica, the CO2 levels were lower and the temperature was also lower. So something very different from what happened on the Australian continent. Let's go at sea. The best French restaurant on the ocean. And I'll tell you, you should see the fromage, I would say, the cheese room. They have cheese for 1 year on this ship, and it's worth spending a few minutes there. And they also can take very, very long course. And you can see here a close to 40 meter pipe, and the gray mud on the outside shows that the core has penetrated 32 meters of sediment. And again, the sedimentation rate is that 1 centimeter is about two years. Okay, so we've got these archives we can compare, and it's a lot of work. And we got the course in many years ago, and it took several years to extract the information. Sometimes we are unlucky at sea, and we send another corer and we hit rock, and we end up with a bent core. And we waste a lot of time, but c'est la vie, as they say. And so here's a photograph of 2 students on the ship logging the core. And you can see, maybe you can see on the right-hand side, change of color and so on. And so we have taken sample every 2 centimeters for several meters, or 15 meters or so. So it's a lot of work. So these 2 cores are their location, one near Kangaroo Island and the other one offshore the Otways. And you can see they are under the influence at times of the Lowen current. The red color shows you a warm current, but at time it didn't function. So offshore Kangaroo Island, again in yellow, is sea surface temperature. We were able to reconstruct from the composition of organisms that are found in the core. And We also looked at little creatures that live in the ocean. There's some sketches there, and their abundance relates to the stratification of the ocean. And we can tell when they were growing in a La Nina period or El Nino period. So that's what we were able to do. Offshore Victoria, 600 kilometers away from that core, same pattern. Again, look at the red bars. And also, we have spent, it's worth working with Germans because they have a lot of money and they pay for 27 radiocarbon dates at $500 a day, okay? They're my best friends, in summary. So the lake records, again, that period that I mentioned before, a lake with it air temperature, very little wind activity, Pomaderis, that plant that doesn't grow there today, and what's happening with the vegetation and what's happening in Antarctica. For the marine records, the two cores, the one from New Kangaroo Island, sea surface temperature. By the way, pay attention that from about 5,000 years ago, temperature progressively dropped by 2 degrees. Today, we're going back up. But the trend is there, like the core that I showed you from Northern Australia before. And again, a La Nina period there. And then we looked at glaciers in New Zealand because they're also affected by ocean temperature. And in blue at the very bottom, the curve for the two crater lakes in Victoria. So here's some images of Lake Tekapo area in New Zealand, and they dated the moraines. They even spent more money to date the moraines. But there's an absence of moraines between 5,000 and 8,000, except for 3 moraines that were active around in the middle of it. And now you look at, these are the moraines again, and you can see there's a sea surface temperature change in Australia. So the Americans who are working in New Zealand are very impressed with the coincidence between our records and theirs. So going back to human presence in Australia, here are the black dots that are very important to realize. These are for human presence for the Holocene. People were everywhere, okay? And Alan Williams and his colleague have said that there is a resource abundance in early to mid Holocene when there was a lot of water and a longer patch residence time and a development of low-level production. But we go back to other places, and those of you who know a bit about Menindee and Lake Menindee and the Darling, you can see that these lakes were filled with water, and the black dots show people were inhabiting in the vicinity of these lakes. However, between 9,000 and 6,000, people moved to the east. Today, this is a satellite image that shows you this area is extremely dry. People were living there because the climate was very different, okay? And that's important to recognize. And then they moved back to the original site, a bit like what happened in Africa that I mentioned before. So I'm not an archaeologist, and I just read the literature by Peter Coates and others who looked at archaeological surveys in Victoria, and they actually found these mounds in the vicinity of the River Murray. And here's a photograph taken in 1918 and with a mound. And I'm going to be very careful here because skeletons have been found in some of these mounds. People were living there, and I decided not to show the photo of the skeleton, but a drawing that was produced at the time. Now, what I discovered also, another survey, you've got Lake Borlaug near Mount Hamilton. The black dots identify mounds everywhere. And I must admit, I have crisscrossed this countryside. I'd never seen them. I was unaware of their existence. And I'd like to go back and have a look. But people were living in agglomeration very close to rivers. Let's go to other places in Australia where you have earth mounds discovered in Northern Australia, in South Australia, in Victoria and New South Wales. And here is a detailed archaeological work done with some LiDAR photographs showing occupation around rivers. And the archaeologists say people were living in large groupings, villages and hamlets around water bodies that suggest our ecological hotspot. But when? After 4,000 years ago, after that wet period, a warm period. Another site in South Australia, again, some mounds. And the eldest mound dates to 4,800, 4,200. After this very wet period, when ENSO, the alternative between La Nina and El Nino occurred, they started to settle down, and not before. And again, another floodplain with new radiocarbon dates published only a year ago, showing a broadening of the diets in response to environmental challenges and the sort of demographic social factors. So a very big change. And now I read a paper that was published last week by Michael Bird and others from James Cook University that fire activities in Northern Australia near Darwin changed completely around 4,000 or 5,000 years ago. So climate really affected human population. So the summary of my presentation, during the Holocene, it is a period of time that stands out. It was wetter and warmer. The ocean currents were very different. The East Australian current, I'm not too sure, but the Leeuwin current south of Australia was extremely strong and very warm, and bringing tropical faunas or where you don't find them today. And the westerlies, is very important, winds that bring the rain, were further south, okay? So the climate was much, much more kind. So it was the equivalent of a continuous La Nina phase. And it lasted, the dates are here, you can read them. And I'll have to thank many people, Peter Kershaw and many others. But I have to, especially in the middle of the slide here, mention all my colleagues and students who this work wouldn't have been presented here without their help and their interest, their enthusiasm. And we definitely had an international laboratory. And my first PhD student is sitting here in the front, who actually had been at sea before me. So these students taught me how to take course and do things like that. So I benefited very much from that younger generation. Then the Australian Council provided me with a few dollars, and the French Polar Institute with its French restaurant, which I will never forget. And being a chief scientist, I was at the table with the captain, and I had a bottle of wine at lunchtime and at dinner time. But during the 3.5 days near Kangaroo Island, I didn't sleep. The adrenaline was strong, and we just worked day and night. So I think I thank you for your attention. And if time allows, I can talk about a pygmy possum, but
Yes, we can.
yeah, but
Please thank Patrick. So what do we need to know about pygmy possums?
well, I'm very optimistic because I knew they are threatened. They were threatened recently by the major bushfires, and there's been an interest in actually bringing them from food down the rock screes and so on. But I have an optimism that they will survive the change in that area, although there's more roads and there's more habitation and so on. But I think and I think the vegetation will change too. And I think Pomaderus, that plant that I mentioned, will come back up there.
Well, there are some people in the audience who might have some questions on exactly that, about food source for possums and all sorts of things. Anyway, I think I won't ask. There's many people here, and I know there's about perhaps 30 online, and there'll be lots of questions. So can we begin? I was fascinated. I've learned a lot, and I had really enjoyed your presentation. It was terrific. So what about some former students? What have you learned? What have you learned again tonight? No pressure, but
Back to Western Victoria, Patrick, and of course, eucalyptus almost completely replaced casuarina at around about 7,000 years ago.
Yeah.
So nearly, from Geelong to the border was all casuarina. Then by 6,500 years ago, it was all eucalyptus.
Yeah.
How does that fit in with this hypsithermal?
Yeah,
8 to 5.
There's an issue about the vegetation in Western Victoria because there's the uniqueness of the soil. Okay. Whereas we now know, I looked also at the vegetation before the Holocene, during the glacial period when sea levels were 125 meters below that today. Casuarina, no, calitris, the native pine, was everywhere. So when you drive through the hay plains and there's all little pockets of calitris in Canberra, I think they're a relict forest from those glacial times when the climate was extremely dry and much colder. Temperature was 8 degrees below that of today, but there were people around. So very important.
how's everybody dealing with the time thing tonight? It's really cool, isn't it? Yeah.
Well, feel obliged to ask a question then. First, I want to thank you for your mentorship, Rick, and it was really nice to be your student, the first student, long time ago. Yeah, I wanted to have your opinion about the fact that El Nino started 5,500 years ago. What triggered it, in your opinion?
I don't know. And the people in New Zealand, the Americans who start looking at the moraines when there were the major changes, they don't know. They know that it links with the westerlies. The westerlies are very, very important in our region. And when the westerlies are very strong in winter, the climate in Victoria is not that comfortable. And but at times the westerly move further south, and it's very rapid, very rapid. Yeah.
And what's happening today? Because we know that the anticyclones are now moving further south with climate change as well, and that's presumably having a similar impact.
That's right. Yes, and I am very curious. I've looked also in some of our work at the core that we've got offshore kangaroo. It's opposite the mouth of the River Murray. So in that core, there's all the clays that come from the River Murray. And we actually have been able to identify that Southern Australia has different clays than around the Darling, because of the geological formations are different. So for the first time, we were able to say when the Murray was flooding water from the Darling and not from the south. And so and the vegetation was different too. So, and we know also that the rain in the Darling area and its catchment comes from the north, not from the south. So we need to know more about it. And I regret in many ways that a lot of ecologists and meteorologists only look at the last 100 years. And going back to the Holocene, we can actually identify significant changes, and people ought to appreciate that.
Okay, so I can't see any questions, so I'm going to ask another one. You got some online? Okay, let me ask one. So the Prime Minister I know gave $1 billion to a new Australian solar panel manufacturer that located in the Hunter Valley. If you had $1 billion, and perhaps the Germans haven't got quite as good food as the French, have they? But if we had lots of Germans who wanted to spend on things to do, what do we need to do? What would be the one thing? What would be the next voyage or the next trip or the next 12 months that you'd like to see done?
I would like to invest in the young generation, get the kids in school more interested in this exciting science, and to also realize there's a future for them doing science. And there's a lot of things that we need to explore further, and we need these new brains. Mine is aging somehow, but I would like to invest in human resources.
So what's the quick? Well, okay. So we have a new group at the Royal Society called the Emerging Scientists. With their undergrads, scientists, lots from Monash. What's the question you want them to answer?
I would like them to invest in multidisciplinary science. I think if you just do one thing, and you've heard that I'm interested in many different things, but it's by combining these information. So multidisciplinary science, read a lot and travel a lot and go abroad a lot because science is international.
See if you can get yourself a spot on the French. Catriona.
Yes, thank you for the presentation. I'm passing along questions from online. We've got lots of people listening in online, but please do stay by the microphone because otherwise they won't hear your answers.
You can speak a bit louder.
Speak up loud.
Yeah. So there was a mention on one of your slides around anthropogenic change in relation to river sediments. So someone was just asking if you could expand, please, on anthropogenic changes that are causing the river sediments to change too.
I'm not sure if I heard a question.
It was about anthropogenic changes with river sediments.
Yeah.
Yeah, but I would like to say that people have been in Australia for 50,000+ years. They have changed the vegetation. They have changed the climate indirectly. People are now very much aware that if you burn the vegetation, the runoff is very different. And it's so practices have been for a long time. We know from a core at Lake George in Canberra that people have looked at charcoal in the core going back 600,000 years. And there's statistically a bit of charcoal now and again. And then there's a period of time when there's a huge amount of an increase of charcoal. People say that's humans. I'm not going to discuss the date because that's controversial, but it's human. And what happened? The vegetation spectra changed. There were more fire-tolerant plants, the eucalyptus and so on, and many others intolerant disappeared. So humans, for a long time, have affected the Australian continent. We need to acknowledge that. And we also need to know that in the last 200 years, and at Lake George again, charcoal increased more because there's more burning, but the vegetation has changed. Yeah.
Duke of Veltus is one of our Royal Society councillors.
Yeah.
So much. This really brought back so many good memories as well of I was traipsing across different landscape myself. And one of the things that you picked up on just now was the need for interdisciplinarity and transdisciplinarity. And one of the things that I loved about your presentation is it shows decades and decades of literally having your feet on the ground or on a seaboat. And I'm curious to ask you, could you expand on how does your brain work with the data at the very local scale? You've done almost a hyper local, and somehow you've managed to combine everything from the hyper local lake to all the way through to the oceans. And somehow with that, you're also investing in terms of thinking about the human side of it. And one of the things, the reason I'm asking this question, a lot of my students now are looking at models and theoretical models, and it all seems really overwhelming where you even start to think about putting that data together. Would you mind talking us through a little bit that process that you go through to connect all these brilliant stories?
Well, my first answer, I sleep very little. And so I have time to gather that data, but I'm very interested in the natural environment. And I've been able to, I gathered a lot of information that perhaps proved unhelpful. But then some spectra of the vegetation and some clays in the rivers have given me some signals. And the more, and also I worked with many people, and their thesis and their dissertation and the articles and so on. And we've been able to match that there were some significant changes. And that's very important. So the young people, I would like to encourage, do some chemistry, physics, math, and statistics, and geology and biology. All these will bring you a better comprehension of our environment. Does that answer? Okay.
Do it all, yeah. Is there a question from, here we are, yeah.
Looking at the charts you produce, there's some major variability over a fairly short time scale of 100 years to 300 or 400 years. Do you have explanations for what generates this large variability and what causes it to change from one direction to another direction?
Now, some people are looking at the position of the Earth with respect to the sun and this solar insolation and so on. There's some big trends there, but there are still some other minor changes, rapid changes we still don't know. And I think these are our challenges. I'm a bit scared of modelers because they need to look at my data and see how it fits with their models. Sometimes they don't pay attention to that. And so that's why I'm so pleased to be able to publicize this a bit more. And hopefully this may go on YouTube, and we'll just see. But there are still some, like 18,000 years ago, I mentioned this sea level change. And we know that sea level started rising when the glaciers in the northern hemisphere started melting. And we know that's solar insolation and so on. But within less than 1,000 years, glaciers in New Zealand just stopped working. They just retreated. And in Australia, many of our lakes start filling up. And we are still scratching the surface, unfortunately. But it's better at this stage to document those changes with good chronology. There are many papers about vegetation changes in Tasmania, but these were in the days when people could not afford these radiocarbon dates. So there's some amazing data sets from Tasmania with 1 or 2 dates. We can't work with that anymore. Today, people require a lot of dates. And the 2 crater lakes in Western Victoria, we now have a huge amount of dates. But when I did my PhD, my supervisor paid for 2 radiocarbon dates. That's all he could afford. Now people can get 400. And it makes a big difference of understanding the changes. Yes.
I have a philosophical question. So does your study of all these changes that have happened in the climate and how humans and plants and animals have adapted, does that give you hope for the future with the changes that we are facing due to industrialization, to make that a short thing? Or do you feel as though this change that we're facing is different and will be more devastating?
I won't comment about devastation, but what I'm saying that my data or our data is so important for the managers of the landscape. They can see what the changes occur as a result of fire or the extraction of groundwater and so on. There were natural events when the groundwater disappeared or decreased. So I'm an optimist, but I think that we need to feed managers, politicians about some of these changes. They are dramatic, and some of them are reversible, like the CO2 increase in the atmosphere. If we stop producing CO2 tomorrow around the globe, it won't just start to diminish. It's just gonna stay there for a long time. So we need to do more science. We need to be more informative. And also, I discovered that we ran this excursion, Western Victoria, all these people. We did not talk to the local farmers, to the local council, and they were not aware of all the good science that we were doing. So I spent time giving talks to the Camperdown Shire. And I must admit, one day I offered to give a talk at 4 o'clock. Oh, no, that's when we're milking the cows. So we had to postpone that a bit later. No, that's when we're feeding the kids. And but anyway, I passed the message on. And but people need to appreciate this landscape. Western Victoria, with all these crater lakes, tourists do the Great Ocean Road back and forth. Okay, they could do the Great Ocean Road, go through Victoria and look at all the lakes, like in the Lake District. It's very popular. The Eiffel in Germany, there's all these crater lakes. There's so much information they can learn about human and also exploration, and also some of the sad things that happened with the early settlers.
Another question? Oh, yes, there is. Yeah, follow up.
A follow-up. From the geological record over the last 12,000 years and looking at the last 300 years, what are the trends from a geological or limnological perspective that you see, you know, as a bit of a forecast, what might happen in the next 100 years, leaving out the anthropogenic?
I haven't got a crystal ball, but I actually am very scared of the climate change and climate because at some stage, in some places, going to become quite catastrophic. We need to be better aware of the environment and look at periods of time when there were major climate shift and better understand them, and especially the currents offshore, the ocean tropical waves that affect the kelp in Tasmania and so on. There are ways to find out if that has happened in the past. And so we need to invest into those studies. Yeah.
Yes, Rob Day.
Yes. Thank you very much. Really interesting seminar, and I'm amazed that you can actually look at the places and numbers of places that humans were
actually active around these different times and relate them to your story. But is it possible to see how the changes that you've documented between the wetter period and the drier periods that followed, is there any information about how many people were actually living in that general area? Do we see a decline in population as a result of these changes?
I think we don't have enough information to address that. But you saw that map of Australia with a black dot showing human occupation during the Holocene. People were everywhere. And I also showed, when I showed the slides of the two crater lakes, there were two images at the end showing trees. Maybe I can.
Yeah, sure.
Can you?
Not me.
Okay.
Hang on. Here we go.
Go back for quite some distance away, further. Chook, chook, chook. Bit more. Oh, I think this slide. These are trees that some of them are still standing up there on the edge of those two crater lakes, and they were growing 2,000 years ago, indicating the lake level was low. And then there was a rapid lake level rise that buried these lakes. Normally, if you have a slow rise, the waves of the lake will actually remove the soil around the roots and the trees collapse. No, it was really rapid. That was at the time of the birth of Jesus Christ. There was a sudden increase of wetness in that part, in two lakes apart. And now, sadly, Jim Bowler, when he was the deputy director of the museum here, he wanted one of those trees to be actually placed into the museum, because we can actually now look at the tree rings in these trees and tell me more about what the climate was like at the time. But nobody got interested, and the farmers thought, oh, there's some dead trees. They burned them, and it's beautiful wood, but and there were many different species. But there is an amazing event where it just got extremely wet for a long period of time, and then it came down. And in 1847, the lakes near Camperdown were overflowing into one another, and they've been going down ever since. And I think that's a result of the Industrial Revolution in the long term, since 1847. So these ancient archives are very important.
Wow. Catriona has another question, I believe.
Yep. I'll hold it really close. You were starting to touch on those sort of effects that we've started to see post-industrial revolution. And someone is wondering how much resolution you can detect at the surface part of the cores. So in the past 5 to 10 years, is that still sort of holding up, as each centimetre is about 2 years, and we can get that detail?
So I mentioned that you saw my map of Australia with all these black dots outside, and I studied many cores. But then I found a few cores that had high resolution, like the one offshore Victoria, the one offshore Kangaroo Island, where half a centimetre represents 1 year. Okay, so it's a lot of work and very expensive too, but we haven't gone it year by year. But I took samples for the last 150,000 years, every 2 centimeters. So we've got a very high resolution, but people can do it a much higher resolution again. But that's a new generation.
So with that, have you learned a lot about the last, like the most recent years, like 5, 10 years ago?
There are some issues. At sea, the sediment seafloor is like yogurt, really soft. And so when we go with these big cores, the core has an 8-ton weight, 8 Volkswagen on the top of this, and it basically pushes that yogurt away. So we have other cores where we were able to identify the last few years. And we use radioactive isotope, the result of the atomic bonds can tell us where we are. I had an idea of looking at DDT in some of those cores because we know DDT was in the landscape 50 years ago, or maybe 60 now, and this is insoluble. And so there are other ways, and also the introduction of pine pollen in Australia. Pine didn't exist 150 years ago. So we are able to look at that, and we looked at some of the isotopes. So we've seen some changes, but again, it involves, you can only get 60 centimeter long cores, but that's a lot of information. Some of them represent 1,000 years. But people go for corals and tree rings because it's much more easily accessible. And there's a lot of information that address some of your question in corals. And the example I use with corals, when people started to clear the land in Queensland, there was a huge discharge of clays at sea, and the clays carried a lot of metals like barium and others, and you find them in the corals. So we can tell the changes that occur. And tree rings are not that easy in Australia because many of the trees don't have that sort of aptitude, but there's much that can be done.
I'm going to give Patrick a break now. He's done a remarkable job, and I think he has, in fact, mapped out at least another 10 or 20 years of science that needs to be done. Clearly, it's there. You've given us a most comprehensive. It is a wonderful intersectoral cross-time through a range of sciences to understand some things that are difficult for a lot of people to understand. But I think you've actually enthused us that and told us that there is already a lot of information that could be drawn on, that we all need to take more interest when we go travelling across the landscape, either in Victoria or elsewhere in the country. But we do need to know a whole lot more, and it's there to be learned about. Would you please thank Patrick for his wonderful lecture? I now have the great pleasure of moving to the more formal component of this evening's proceedings, which is the awarding of the Royal Society of Victoria's Medal for Excellence in Scientific Research. The medal's been awarded by the Royal Society of Victoria since 1959, when the Australian research sector was still quite young and growing in strength. And our first medalist was also an earth scientist, a geologist from the University of Melbourne by the name of Dr. George Baker, whom I'm sure would be pleased to know that the tradition continues 65 years later. As President of the Royal Society of Victoria, it's my great pleasure to honour Professor Patrick de Decker, AM FAA, with the 2023 Medal for Excellence in Scientific Research in recognition of an outstanding career contribution to our understanding of the interactions between the changes to the Earth's systems through significant discoveries in the fields of limnology, paleolimnology, paleoceanography, and micropaleontology. And I present you now, Patrick, with your medal.
Oh, thank you. And my surname is spelled properly.
You know, we're good at that here. We're good at that here.
Okay.
Yeah.
I'm very chuffed. Thank you very much. And I hope that my message in the video will actually stimulate a lot of young people to be ambitious, just like Jim Bowler was ambitious with his Salt Lake program. And at first he said he was a bit reluctant to see me going at sea, but I think I've done quite a few things that I'm very proud of.
And
But it was-
he is too.
And through the help of many students and postdoctoral fellows and so on. Thank you.
No, it's a pleasure. It's a pleasure. Now, ladies and gentlemen, may I invite you to join us downstairs for some refreshments. Thank you for being with us tonight, and thank you online as well.